Alrighty, we're looking at transformations, and a transformation, if you look at the prefix transform, it really is referring to changes that we're going to be making to functions. So the types of changes we're talking about, we may be taking a function and shifting it up or down, left or right. We may be stretching it horizontally, shrinking it horizontally, or stretching it vertically, or shrinking it vertically. We're just going to focus on some shifts left and right, up and down, as well as some reflections, and then in class we will talk about some of the more complicated ones. Okay, so to start, if we're talking about vertical shifts, this is where we have a function of this form, f of x plus k or f of x minus k. If you have a function and you add a value k onto it, it really means that we have a vertical shift up k units. And likewise, if we're subtracting k onto a function, we have a vertical shift down k units. So the idea is if you have something like y equals x squared, we'll keep it simple. We know what this looks like. Okay, the vertex is right here. Sorry, it's kind of sloppy. At 0, 0. If we were to take this function and add 5 onto it, well, now all of a sudden it's going to be going up 5. The width is going to stay the same, and my new vertex would be 0, 5. Okay? Or likewise, if we do y equals x squared minus 2, well, now you are shifting it down 2 units. Same idea. Now your vertex would be 0, 2. Okay? So when you add a number, which we're calling k, onto the end, we are referring to a vertical shift up or down. Okay? Next, let's talk about some horizontal shifts. So horizontal, of course, is left or right. So these functions are going to take on this form, or these changes will take on this form, f of x plus h, or f of x minus h. Okay? So the idea here is if we're looking at the first one, f of x plus h, here this is referring to a horizontal shift h units to the left. It's the opposite of what you would logically think. You're actually not moving to the right h units, you're moving to the left h units. And in a similar manner, if you have x minus h on the inside, here we have a horizontal shift to the right h units. Okay? So suppose we're talking about something like f of x is equal to something like x minus 3 squared. Okay, the parent function, the starting function, is x squared, just like we saw up above. So suppose we're now taking that and we want to apply this change in the inside of minus 3. So if we were to compare it to y equals x squared, so now what's happening is our vertex 0, 0 is going to be shifted over to the right 3 units. So our new function would look something like this with a new vertex at 3, 0. So the first function has a vertex at 0, 0. So if we have this change going on, then what's happening is the function is just moving 3 to the right. Now, sometimes you might see more than one change. We could have a situation where maybe we define a function g of x, and maybe this is x minus 5 squared plus 4. Well, in this situation, we would be looking at both a vertical and a horizontal shift. So we would be going to the right 5 and up 4. So if I were to take my parent function, my starting function of x squared, okay, you can see there's a square here, so this suggests my parent function is just y equals x squared. Think of this as like an offspring function. So if I started with x squared, my new point here, if I were to go to the right 5, so starting with, imagine grabbing a hold of this at the vertex and now shifting it to the right 5 and then up 4. So now my new parabola would look something like this, and my new vertex would be to the right 5, up 4, so 5, 4. Okay. So what we tend to do is we use vectors as a way to actually summarize these shifts, both left and right. So let's jot this down. We're going to use what we call vectors, and we have a whole unit on vectors. But for now, this is the form of what a vector looks like. All right, you have two numbers, one on top of the other. The x number is always on top, and the y number is always on the bottom. So we're going to use vectors to demonstrate horizontal and vertical shifts. So in other words, up here, if I were to look at this example, I could have said that these changes of going to the right 5 and then up 4, if I'm going to the right 5, I put a 5 up top because that's where my x is, and then a y is on the bottom, so 4. Alright, so that would suggest a movement of 5 to the right and then up 4. Let me give you one more quick one. If you see something like the vector, -2, -3, this would mean, again, x is on top, so the x movement is -2, so we'd be going 2 to the left, and we'd be going 3 down since the y movement is negative. Okay? So it's just another way of telling you what the changes are. Sometimes you'll see, especially in IB problems, they'll tell you that there's a certain transformation going on according to this vector. Okay? So when we talk about vertical and horizontal shifts, okay, these are known as translations. It's a fancy word for shifts. Okay, so the title of this is transformations, so that's referring to changes in general. If we're talking about a shift, either left or right or up or down, we use the word translations. Okay, so now the last thing to talk about are reflections, and again, there's some more complicated ones, but we'll be discussing those in class. There's two here to discuss. If we negate a function, what happens here is this ends up being a reflection over the x-axis. Recall from your geometry days, that's how we say reflection over the x-axis. And if you were to do f of -x, so negate the inside of a function, this is going to be a reflection over the y-axis. So just a couple quick demonstrations. So if you have y equals x squared, okay, if I were to negate it, so versus y equals -x squared, if I were to negate that function, well, we know that x squared looks like this. Negating it would flip it over the x-axis, so this is y equals -x squared. Okay, so this, of course, is my x-axis, so the vertex would still be the same in this case. Okay, so we are just flipping it over or reflecting it over the x-axis. Okay, if you have, let's consider the function y equals the square root of x versus y equals the square root of -x. Okay, notice how this time we're negating the inside. Well, if you were to graph this or these two functions, here is the square root of x. Now if you were to negate it, alright, what you would see is that it looks like this. Okay, So you have negative x values here, but when you put them into your function, there's a negative in front of the x, so that's making them positive. Okay. Well, notice this is a reflection over the y-axis. So the things to remember here, if we're talking about reflections, if you are negating the function itself, and think of this as really being negative y, since f of x is really y, so you're negating y. So if you negate a y value, okay, then you take a point right here. Suppose we're talking about the point 2 comma 4. Alright, you negate your y value, keep x the same, now you're at 2 comma negative 4. Okay, and likewise with the next one here, you're negating your x. Okay, so maybe this is the point 9 comma 3. Okay, that would fit on that function. Well, over here, well, this is not drawn to scale, pretend this is. Alright, this would be negative 9, 3. Notice how the x is negated and y stays the same. Okay, thank you. Bye-bye.